Okay, so a little background. My friend gave me this Nintendo Game Boy that used to belong to her father, and she says, hey, you know, the screen doesn't work and there's no sound. I don't think it works at all. I think it might be broken. Would you mind taking a look at it? I said absolutely. So figured I'd make a video about it. Today we're going to be taking apart this original DMG Game Boy and seeing what's wrong with it, seeing if we can't diagnose it, and then after that we're going to be heavily modifying it after we get all the parts together and confirm that it's working. See if we can't breathe new life into this machine, because well, they aren't making them anymore, and you can throw as many mods as you want in one of these things. They're not remaking the original CPU. Everything else, I mean, there's tons of accessories out there that will emulate a Game Boy, but it's not the same, I feel, in spirit if it doesn't have the beating heart present in the original, which is that CPU. So I want to salvage this thing if possible. Now, it's a bit beat up. It was in storage, I believe, and that is probably a contributing factor into why it doesn't work, but we shall see. How's the focus on this? There we go. Now that we have the camera fixed a little bit, we're gonna take this thing apart. Well, actually, first, let's give it some power and see if we can't see anything. I just want to confirm that we are actually getting no sound and no screen. So we're gonna have to hook it up to power, pop in again, and then see if what she's saying is reproducible. We got our ESD on, just in case. Probably not strictly necessary, but I like to play it safe. Okay, we take 4 1.5 volt batteries. That's 6 volts. I'm just going to confirm that it is basic math, but any opportunity to show this beautiful Commodore branded calculator 1.5 times 4. Wow. We all knew that, but it's so pretty. I wonder if it looks better in the dark. Yeah, look at that. Anyway, there's the model number for anybody interested. 6 volts. So we're gonna hook up our bench power supply, turn that on. Once it is good to go, it starts there, goes there, bridges here, so that's negative. See if we can get a good grip on that spring. Actually, let's tilt it the other way just so we don't accidentally short this thing out. Okay, and all right, looks like I'm just gonna have to hold that one for right now. Well, if I'm gonna have to do that, let me go ahead and turn on the power supply, bring us up to 6 volts. Bring the coarse up and bring the fine. 6 volts flat. Oh, well. Split the difference. There we go. Perfect. Press that in there. Try to turn it on. Nothing. Okay. I'm not getting any movement on the power supply, so yeah, there's not a dead short, there's nothing in there, so it's just fully disconnected. Cool. Well, now we know. Well, just to be sure, let's pop a game in here. The modders amongst you will recognize Perfect Dark. I'm using it for exactly what you think I am. Nothing. All right, so we got no power at all. Hopefully that'll be easy. Let's turn this power supply off. I'm gonna get out what I need. You, and you. One of the things I like to do is just set these in the same order. I'm sure most people like it. God damn it. Okay, there we go. I like to set these in the order that I found them. Same orientation. There we go. I believe there's 6. Yes, 6 in total. You know what? Actually, before I take the rest of these off, I'll make it a little bit nicer on the hands and clean it off a bit. We got 91% isopropyl, or isopropyl alcohol, or rubbing alcohol, whatever your preferred term is. Now, I prefer the 91% because it has way less water in it. We're gonna actually need the toothbrush for this. really get into those letters right there. Okay. Down this dry. Wipe up some of this. Get some leverage here. Now, even though I'm going to be removing this and putting it in a different shell, I am going to keep the shell because I might need it later. That's not ideally clean, but it's cleaner than it was. Let's get this cartridge port. And now you can see why there's so many stains on here. It's because it's stuff like this. And no matter how many times you wash this rubber sheet, it'll still leave some stuff there. Although I haven't hit it with OxiClean yet, and I might do well to do that. Although I am curious how it's going to react with the rubber. Come on, I'm really trying to focus on this scratched up part right here. Now, even though this is, kind of grungy, it is weirdly enough kind of nice to see because it's so scuffed up right here because there have been so many games pushed in and out of this thing. There have been so many games that have been inserted into this, meaning that this thing is clearly well loved. There we go. Yeah, look at that. All the scratches from years of use. Love that. Fighting the urge not to just dump all this just right on top of it, but let's get these grips. And I'm gonna have to wash this mat after this. Actually, yeah, I should use the OxiClean and see if that works or not. If it breaks it, or discolors it, or warps it, or bursts into flames, who knows? It's a good excuse. Red alcohol. It's a good excuse to buy another one. They're only like, this is the the Walmart own brand, so it's like what, $12 or something, maybe $20. Who knows with surveillance pricing nowadays? Alrighty, a little bit more. It actually looks a lot better right there. Let's look at that. It's a pretty heavy stain right there. What's that? Oh, it's tape. Okay, that makes sense. That's way better. I thought it was like a chemical burn of some sort. Oh, we'll peel that off later. Let's get this side. Come on. I'm sure there's a little bit right there. I'm trying to get in that little. I'm sure you can see it in that fin right there. Yep. All right. Got to use a little bit more precision. There we go. That worked just fine. That's already looking way better. Oh wow, look at that. I don't know if it comes up in the camera, but it's already a shade cleaner. It's kind of therapeutic doing this. Especially where what's hiding underneath is so nice. Get these ridges right here. That's like new. Well, other than that right there, but nice. Okay, how's this look? That's good, good. I'm just gonna use a little bit more care. Get the bottom real quick. Get the round bit. Wow. Okay, and now the front, which is arguably the most exciting. I don't know. Comment down below if it's if you prefer watching the front be cleaned or the sentences in the back. I gotta hit this too. I'm gonna do that last though. See, the thing is, these always look way worse than they actually are if the frame right here falls off, because all you see is this glue, and the glue's gonna pick up dirt and stuff like that. No matter how old it is. Let's get that speaker. The good part and the bad part about alcohol, 91%, is that it evaporates so fast. A little crazy there. Oh, that's awesome. Evidently this thing has my old hometown's logo on it. Just GG chat just got doxxed. Try to stay away from the screen here. Okay. Another look. Oh, I guess I did touch it a little bit more. Hold on. Didn't put any pressure on it, which is what I'm worried about. And we are out of alcohol again. Another top up. Sure, just spill that anywhere. Put elbow grease into that one. That little black bit is. There we go. That looks way better already. Look at that. This is going to be difficult, so I'm going to dump this in there. That's the point of the isopropanol, is it's going to evaporate really quick. And if there's any water in here, which I doubt there is, it's been inside for many weeks. But if there was, it would bind to the water and pull it out, kind of like it's very similar, if not the exact same principle as ISO heat for those of you that are familiar with automotive repair or just general maintenance. It'll pull the water out of something, whether that be gasoline or inside of a component in electronics. Now, it's against common knowledge to put water into electronics, but there is a case for it. You do need to thoroughly dry it, and I think you should hit it with some 91% ISO as well, and then also heat and time. Where water and alcohol are two different types of solvents. They are effective against, two different groups of materials. Of course, there's a lot of overlap. Now, some people argue you can use soap, but some people say don't because it can leave a residue. That both of these are true. You can use a small amount of soap, but you've got to be careful on what components you put it on. Gonna hit this again. Okay, there's a little dirt right here. I'm trying to see if I can't get that with this. This is an owl. There we go. You don't want to press too hard because you don't want to scratch anything. And this thing is perfectly capable of scratching things. There we go. And our dry. Ah, nice. That's out of there. Good. Okay. Let's see if we can't get all this gunk out of here. Just kind of knock all this loose. And now we try. It's gonna go hog wild in here. We're gonna be replacing these springs anyway. Oh, that's way better. Look at that. Nice. Not a lot of corrosion, which is good. Let's see. Well, that light's a little too far away. Okay, not a lot of corrosion here. There is a little corrosion here, and I wonder if that might be near our culprit. This might be a dead solder joint or something like that, something simple. The fact that there's no power at all makes me think that it's probably something like that. All right, in spite of our detour, real quick for the cleaning, let's go back and finish taking this apart. And drop our tools. If you're not dropping your tools, are you even a repair person? Let's be honest. And our final screw. As far as I know, don't make a fool out of me. Now, the big reveal. Let's see if there's anything obvious. Okay. first things first, we have to disconnect this screen without breaking anything. Okay. There we go. Cool. I wasn't just pushing down, I was kind of walking it out, you know. Okay, so let's see what we can see right off the bat. I think it's going to be in the power side, so I'm going to set aside the screen board for now. Okay, there's already little bits in there. Nice. Okay, what do we see? Definitely has that old smell from old PCBs when they off gas. Okay, we got our power board in here. That could be where our issue lies. Okay. Well, for now, let's take our board out and look at the other side. Maybe there's something obvious. After that, I'm going to apply power and see what we can get. Oh, before we start that, let's update our screws. Since I am right-handed, I'm going to move these over. This isn't strictly necessary for the DMG. Most of the screws, as far as I know, are the same size. But if anybody has ever repaired an iPhone 6 screen specifically, and you have encountered long screw damage, you know exactly why I'm doing this, and I'm being very meticulous about which one is which, even if they're in the, you know, quote-unquote same set. I don't trust it. Do I think Nintendo is as bad as Apple about that? No, but always best to play it safe. If you do it every time, you are less likely to forget. No, we gotta do our sound. It's down here, right here, this one and this one. Just got these two. Okay. Whew. Definitely smells like blown capacitor. Eee. Who'd have thunk it? That's what I've been smelling. Is a long exploded electrolyte. Ah, sweet. That means that once we replace all the electrolytics, it should probably turn on just fine. We shall see. Is that everything? Yes, okay. Okay. Walk this bad boy out. Gotta kind of work it with the contacts down there. There we go. We got our back of our cartridge slot. Let's set this aside. And do the big reveal. Okay. That right there is the heart and soul of this. One part they're not making any more of. Well, they're probably not making any more of a lot of parts, but definitely not that one. And this power switch seems like it's seen better days. It's a bit oxidized. So we're gonna have to hit that with some deoxit. Ooh, same thing with this power input. So right there, I don't know if you can see the oxide layer on there. It's pretty dull gray. Okay. DC DMG. Okay. Okay, now we're going to test our power board. Well, funny thing is, I get ready to take voltage tests and I don't have my multimeter. I'm going to have to go to my car and get it real quick. There we go.
peak the 240.
And we're back. Got my multimeter. We're gonna go ahead and turn the power supply back on. Let me go ahead and hit ground real quick. We got our normal power. Okay, and making sure we don't hit a short or anything like that. You know, let's play it safe actually. Let's put a little barrier between that and any metal. Perfect. We're going to be testing this power board. Now I am looking at Gekio's schematics on GitHub. What we should see, the DC board, where's 1, 2, 3, and 4. Doesn't matter, starts at VCC it looks like. VCC is 4. So when we apply power, VCC should be 6 volts. VEE, which is pin 2, VCC is pin 4, pin 3 is ground, pin 2 is LCD bias supply, which is negative 18 volts, although I have seen negative 19 volts in some forms, but you know, let's say any range between 17.6 and 19. VDD, pin 1 is main power supply, nominal 5 volts out of the regulator. Perfect. Okay, so I'll be testing this guy right here. Dude, is it dead? Come on. God damn it, I'll never escape the cycle of samsara. Once more with feeling. Thank you, much appreciated. VCC compared to ground should be 6 volts. Let's turn the power. We're gonna go ahead and put our ground right here. Just let weight do what it needs to do. Okay, pin 4 VCC is this one right here. Oh Christ. Should be getting 6 volts. We are getting 4 volts. 1.5, 1.6. Okay, so it feels like something's failing. Let's go to the next one. Next one should be ground. Should get 0. So that's bad. Anything getting hot? Is the CPU getting hot? No. What I can do is turn the device on, the power switch on the DMG right here, and then actually, you know, measure it how it's supposed to. 6 volts flat. Okay, good. Ground. There shouldn't be anything on ground. There is 5 volts on ground. Okay, VEE. This should be negative 19 volts. That is 5 volts all day. And VDD should be 5 volts regulated. That is 5.6 volts. So, this is not doing its job. Let's see. Let's kind of do some sleuthing real quick. Let's just confirm that what we're getting is 6 volts. Good. Okay, so we're supplying 6 volts as we should. 6 volts down from the batteries. So capacitor C20 should be nothing there. Actually, let's go after diode D1 RB100A. Okay, where are you, buddy? We're gonna hunt for this guy. Oh, right there. Okay, so out of here, we should be getting 6 volts. There we go, 6 volts. That's at that diode right there, right after the line. That corresponds to D1 right here. Okay, now we're out of there. We're gonna check the power switch. We definitely know where that is. Okay, so the diode's right here. 6 volts, excellent. This should also be 6 volts. Yep, and just a sanity check, this should be 6 volts too. Good, cool. Now, so this is pin 1 of the switch. Oh, that's pin 1 of the switch. Okay. Pin 3 should be going to the ground. That is correct. Okay, shouldn't be getting anything out of any of them because the switch is off. Only thing that should be getting power right now is the positive rail of the DC jack. this right here. Where do you go? Anyway, let's turn it on. What I'm going to say is I'm going to go ahead and replace all the capacitors on this board. And as I take them out, I will test their capacitance and see how they're doing. We got our bag of electrolytics. What is this one right? We're going to start with this guy right here. Got a 33 microfarad. Got a 33 microfarad at 25 volts. Let's look at this underneath the microscope. Got a 33 microfarad, 25 volts. Okay. Well, you know, while we're here, why not just look at the PCB? Check for any cold solder joints or the like. Everything looks pretty good. That's a bit funky. I think the transformer's fine. It'd be extremely weird if it went out. Yeah, it looks fine. Okay, let's flip it over. Yeah, it all looks fine. Alright, we'll do our electrolytic test, or replacement rather. That was at 33 at 25. Okay, let's see what we got in our little bag of tricks. What are you? 33 microfarads. Okay. And your voltage, please. I mean, it should be fine either way, but brother, where's the light? There we go. Temperature reading. There, 25 volts. Oh, well, what do you know? Look at the draw. This might be better with the microscope, but I'm gonna see how well just zooming in works. You guys let me know what you prefer to see. Okay. That worked out pretty good. Okay, just a little more on that side. Yep. Nice. Okay. Just trying to get that leg bent out of the way here without delaminating the silk screen. Okay. You fell right out. Now this would have been a good time to check the polarity and remember to do that. Good thing I have video evidence. Now I'll just check the schematic actually. Alright, actually what board version do we have? This looks, look at this. Okay, looks like we have an A2 board. Okay, we got a pin directly connected to ground. That makes sense. We also have a pin directly connected to pin 2. All right, negatives this way. Let's just make sure this is the 33 microfarads. Yes. Okay. Cool. As we can, bend the legs, and while we're Setting that aside, we're going to check the capacitance of this one. Should be 33 microfarads. Oh, shice. Brother. Stop moving, please, God. I'll crash out. 33 microfarads. Come on. We're getting... Oh, okay, that one looks fine. Well, it's a little over, but mostly fine. Could have been good. I suppose we'll see once we resolder everything. Though I am going to go through and do all of them. This guy, that is 100 microfarads at 10 volts. We're going to desolder this guy, and we're going to look. Negatives down. Oh, well, what do you know? They actually put it on this silk screen. Much nice. There you go. That got a little dirty. A little bit of a flux in that desoldering braid. Got a little burnt right there. There we go. Nice and clean. Much better. We're gonna put our new one in there. Getting a little snug. Not too snug, just in case we need to mess with anything. Cool. And I'm just bending these back for right now. Just in case. I think our next target's probably going to be this guy. Is that 1 microfarad? Is that the guy next to him? Yep, both 1 microfarad. So it looks like we got 2 1s, 400s, 2 10s, and 122. So we know where these ones go. There's these pins right here. These 4. You check the polarity. That's negative, but luckily it's still in the silk screen. Pulled that guy out. We'll put him in the little graveyard. There we go. Brush. Once we actually solder these down, we're going to bend them down. You can see where they have this this outline here on the silk screen. That means they have designed this for these two laid down. So there's that's factored into the tolerances. Our next target, that looks like, oh, it's labeled. How nice, 10 microfarad. Oh, yeah, what do you know? One right there, one right there. Man, I love some of these older PCBs because the designers are so considerate to actually write down the values, and also the component names you can follow along on the schematics, which is, you know, it's pretty invaluable. This one and this one. Okay. Or sorry, an hour and 12 minutes long. I'm going to close this video to do a clip. Now, I have to be more careful with this one because there's this IC right here, and we don't want this IC getting too hot, so we're going to have to play it safe. Clean it off a little bit. Really gonna have to wash my hands after this. People often neglect the wires. Don't do that. God, yeah. Man, yeah. Smell tons of electrolyte. And all this is all sticky. I bet all of... Oh yeah, no, these ones definitely blew up. Or failed, they leaked out their electrolyte. Oh yeah, it's sticky. Let me hit this with a little bit of deoxit too. I'm very curious to see what this is going to look like inside this jack. Oh, not that bad. Huh. Neat. Okay. Now let's hit the inside of this with some deoxit. That should be more than enough. Lead free. Because we like having our brain cells. Mind you, this is probably all leaded solder, so, you know, definitely wash your hands afterwards. I'd also recommend getting, like, lead test Q-tips. They're, like, orange, and they turn purplish if they detect even the smallest amount of lead. They're very good to have, especially if you're doing any work like this, or plumbers still use lead. Plumb bum, you know. There we go. You want to heat both the leg and the pad. So that they both are able to accept the solder. That's a little better, okay. When they're both up to temperature, the solder will wick a lot better, and that's what you kind of want. You want that wicking action. These ones are a little complicated, so I'm gonna, or complicated, not they're a little crowded, so I'm gonna kind of bend these this way. You don't want it to wick up the entire lead and then like merge the two. That's not too terrible to deal with, but it's still not fun to do. You know, it's extra work. Should I have done this earlier? Probably. There we go. Okay. Okay, that's all of them on the main board. Let's go down to the power board. Well, here we go. That's an issue right there. This probably happened during our soldering session. Let me get that under the microscope. See that right there? That pad has come up. Right there. You know, not the end of the world. We're just gonna, what it means is we're gonna have to, if it doesn't get a good connection here, we're gonna have to file away a little bit of this this silk screen and solder it directly to the pad. But yeah, that's not uncommon for how old some of these boards are. This almost certainly happened because of our applying of heat and a little bit of a mechanical advantage, let's just say. That is not a great connection. We'll go back to it. Okay, we're gonna have to fix this one. Go. Kind of expose a little bit of that copper. Now you could just take this and just bridge to this component, but this component is really small. It's a little SMD or SMT, surface mount technology. Yeah, SMT component. So I don't want to add any heat to it, even if it's like a resistor or something. If I don't have to. When I have this, like, you know, honestly, the luxury of this very large pad, why not? Or pad, you know, plane rather. We're gonna bend it this way. Now, for those of you who aren't as familiar with electronics, most capacitors don't have a polarity, but these electrolytics do. So you gotta be careful of that. Luckily, the negative is very clearly labeled. Alrighty. Let's get these soldered in. Let's get it in frame. Also noticing it looks like this resistor right here isn't soldered in. Now that we might have done that one with the wick, but let's just reconnect that real quick. Oh dang, what's going on here? Well, if this keeps messing up, what I'll do is just bridge these two directly, you know. All right, we'll do a bodge wire. We're gonna clean everything up with some flush cutters. I got my inside and my outside flush cutters mixed up, so my good ones I used on my car and they're covered in grease, so love that. Anyway, these are really good for clipping these leads. It's very good to hold these while you clip them because they will fly into your eyeball or just randomly. And that is not good, especially if you have pets. Oh my gosh, look at this. Look at this. This pad just came up. Jesus. Still connected, but oh, that's not good. This board might need to be replaced completely. It's delaminating everywhere. I have to glue everything in place. The electrical connection's still there, but you know, gotta be wary. Yep. Look at that. Another one. I might be keeping these legs for the bodges. We're gonna be a little bit more gentle with the rest of these. As in, we're moving on to the power board. As in, we are moving on to, or as in, we're anchoring these at the fulcrum. That one actually didn't turn out too bad. Anchor at the fulcrum, then bend up. Cool. All right. Now these have two different. These ones have two different silk screen colors, which means that I'm at least hypothesizing that this is going to be a little bit more resilient than these auxiliary boards. I know that these power boards went through many different types of iterations. At least I know that now. I should check back to make sure that I covered that right. That might be the reason, you know. Just make sure those aren't touching. And now we're gonna go clean these again. Oh wow, the camera really doesn't do it justice. This looks really nice. Before we do that, let's test those capacitors real quick. We're gonna hold y'all like this and wedge it in. .4 microfarads, and you're supposed to be 10. That's not too far off. You're probably fine. 100. 102. You're pretty much fine. This one should be 1 microfarad. Oh, yeah, 1. Actually, pretty good tolerance. You should also be 1. 1, okay. You should be 10. There we go, 10. Okay. 100. 102. 101. Okay, that one is good. 100. Okay, 100. 116. Okay, those are the two that came off the audio board. So, and those are the only ones that seem to be pretty out of spec. I just don't think that is going to be the reason why this isn't working. So we're going to investigate a little bit more after we clean it up. Now, I'm going to hook it up like this. Okay. Supply our 6 volts. Power. Nothing. Okay. Well, are we getting the correct voltages? Put this in frame here. Okay. VCC. .6 volts. Next one should be nothing. Still 5.6. How about you? Should be negative 19. You're 5. What's going on here? One volt off, which shouldn't happen. 5.6 volt on, which shouldn't happen. There should be nothing here. Okay, we're gonna do a continuity test. Let's turn off the power. So this should be ground. Is actually right here on this big old pad. Good. Interesting. We're not getting continuity with this ground. And all those grounds should be tied together. So, we're going to look at those traces. Ground is second one, which comes in right here and is completely covered by shield. That's awesome. We're just looking at these traces. Okay, it punches through here and is covered by the connector. Oh my god. All right. We're gonna have to look at the schematic, I think. That's exactly what we're gonna have to do. Let's just check continuity here. Okay, so this is getting continuity here, but not here. What about whoa, whoa. Oh, well, that's positive. That makes sense. Ah, see that right there? Continuity here at this point, but not on the spring. Okay, so let's do it right here. We'll touch the back of the plate and then the plate itself. Where it connects. But when you touch the spring, you hear that? I'm not moving. It's intermittent. I think it's so heavily oxidized that it's doing that. We're gonna have to remove this anyway. Okay, I don't have a suitable replacement for this, so we're gonna just desolder it, take it off, and clean the shit out of it, and just clean it up as much as we can. Clean up the connection point. Okay. Set you over here for the time being. We look at this. Oh yeah, that's all messed up. It's all corroded. How are we gonna clean this off? Well, we'll try alcohol first. Oh, that actually did pretty good. Too. Something. Actually, you know what? I'm gonna take it from right here. Since I have replacements for this. Yeah, we'll do that. We'll do that. Shape. That is significantly less corroded. Now is there a place to mount it? That's the issue. Oh wait, we can just rotate it. It'll be a little off, but it's better than nothing for right now. No, don't want you to bend right there. Oh, no wonder there's nothing holding it on to begin with. All right, well, round two. course. Should I go back to this one? Probably not. Actually, no, I can just solder that back. So, yeah. We'll stay at it with this one. Okay. I'm trying to keep a lot of these mistakes in here. Well, I say mistakes, developments, you know. That way, people can kind of learn that if you run into a mishap like this, it's not the end of the world. As long as you're able to formulate the next step of the plan, you can kind of accomplish anything. There's a really good line in The Martian to the last scene where he says you solve one problem and then you solve another, and then if you solve enough you get to come home. And that's kind of how I always approach groups of problems like this. Is I yo-yo between two extremes. Either it doesn't really matter, it's not the end of the world, they're not going to take my birthday away or something, and then but on the other hand, sometimes I'm like, you know what, no, we're on a derelict ship and this is the only way we're going to keep oxygen, so I can bring out my best work, you know, under pressure. But I'm one of those people who works pretty good under pressure, but to each his own. You know what, let me use the broken ones, the ones with the tip broken off. There we go. Delicate work here. Now we kind of got the shape we want. Perfect. And then we're going to have to repair that a little bit. Okay. Somewhere to hold this down. These little alligator clips that aren't attached to anything, super useful for stuff like this, really. That, and also, you know, temporary connections. That way this isn't going to like move around as much. And I can also have a little bit of distance and anchor with my finger. Okay. We are gonna have to use a little bit of flux, but put that right in there. Okay. Are we joined up? Yes, we are. Nice. Okay. We're also going to reinforce the other side because it got bent pretty heavily, and it's almost certainly experienced a lot of metal fatigue. So that side's reinforced. This side over here is reinforced, and the other side has been repaired, or at least joined together. So this is now a solid piece. And the lead. It's a little off center, but that shouldn't matter all too much with the spring being kind of variable. But I suppose we'll see. I'm gonna pretend that that's not 1,000 degrees in my hand. Oh, it's close. Oh, there we go. I had to force it just a little bit, but where it's a little bit snug, we got a good connection. Cool. Ooh, there's something. This one sticks out a little bit. This is a little recessed. This is where it bends out. Is the other one like that? Look at the original real quick. The original does go out a bit. Yeah, that's an issue right there, yep. See that? It's off. What to do, what to do. Could just send it. Nah, we're not gonna do that. That's dumb. Well, back to plan one. Cleaning this freaking thing. So we're gonna have to get the spring out first. Which looks like we're gonna have to have an... Oh, don't do this. This is a sharp and I'm gonna be applying pressure. I can easily stab it in my hand. And I don't know if you can tell from my finger, but it's not my first rodeo when stabbing myself in the hand or trying to fillet my fingertip off. That sucked, by the way. Don't do that. I'll tell that story some other time if you guys are interested. Okay, rotate you out. You're a little bent, but whatever. You know what? I'm gonna scrape this. We're gonna hit this with some deoxit. This is mostly cleaned. It's not going to get perfect, and I don't have a replacement bit. So what I'm going to... Oh, that's got bent out of the way a little bit. What I'm going to do is I'm going to reinstall the spring. Clean off all this deoxit, just in case. Use some ethanol. Not ethanol, Jesus. Isopropanol. And then I'm going to solder the spring to its base. That way there's a solid electrical connection. Alright, we're going to solder that like that. Now the other side. There we go. Don't do that, by the way. I worked as a cook for many years and don't really feel anything on my fingers anymore. Also a hobbyist blacksmith and work with electronics, so it's surprising I can actually feel anything at all on my fingers. Oh, that's awesome. I'm melting the pad. Whoops. Oh well. Oh, yucky. Oh, Jesus. It's even on the spring right there. That's not going to work. Let's cut that. Okay, that should not be as solid as it is. Yeah, well, that's soldered on there. Cool. Clean up all that flux. Outside of that detour, that totally didn't take 45 minutes to do. Let's take the old one out, the one that does not do its job. This is stupid, do not do this. There we go. As I thought. There's a little solder in the way. Okay. Let's resolder that. Pretty good. Now, let's test continuity. Ah, there we go. Way better. It's gonna be so funny if that's all it was. It's just corrosion on the terminals. Mind you, the audio was probably terrible on this thing, considering it was, those electrolytics are leaking on the audio board pretty heavily. There we go. Power on. Oh, Looks like that's what it was. All right, well, let's see. Let's just confirm. Let's not get too crazy, not get too excited. Let's move these guys out of the way so that we can have room for our cart. What game should we put in? Let's put in... Got a stack of the games that Despa Development has made. And let's see. Let's do the one we're currently working on. Get a little sneak peek. No, this is Perfect Dark. You know. If you know, you know. It's good. It's a good test cartridge. It should be Retro Tarot. Let's do it. Yep, sure enough. Everything works. There's a little issue here. Where's that contrast wheel? Okay. I don't know how much you can see here. Let's get a little closer. Alrighty, I'm not sure if you saw that, but there's a little bit of a line right there through the screen, which is a common issue with these old DMGs. So what we're gonna do is we're gonna take the screen assembly out of this side of the shell, and then we're gonna do our little fix and see if we can't get this to work. But it's gonna involve us putting all this back together. Well, actually no, we can make do without that. Okay. Just gonna make this a little easier for ourselves. Set this over here. And then we are going to begin taking this apart. I used to have a magnetic mat. No idea where that is now. Gently lift. Turn this over. Oh, there's definitely some gunk in that speaker. Surprised it works so well then. Gonna hook you back up. Right in there. Fold it back. Really, would be really nice if this wasn't aluminum. You know, a non-conductive material. Let's see if we can't get a good angle here. That is probably the best we're gonna get. We're gonna use this invoice as an insulator. This one says Hime's Quest. I think this is Haiku. We'll see. That's our horror game. Let's see if we can zoom in. Alright. You see that line right there? That's what we're working on. So luckily, the way this is fixed, it's pretty simple. You just gotta press against this rubber bit. Well, I say press very gently. You're gonna heat it up with a soldering iron. turn it down just a little bit. As it cools down, you can see the connections reforming. And there we go. clear screen. Oh, one of them popped out. There we go. Oh. Well, we can't have that. There we go. That is a fully repaired DMG screen. Okay, now this is the point where I would be like, alright, cool. Now, this is the point where I would put everything back together, show you a finished Game Boy. But since the next video is going to be us modding this board into a new case and everything, I think I'm gonna end this video here. So, and you know, in summary, what we did, we replaced all the electrolytics, we cleaned the thing, and we found that ultimately the issue was a combination of some blown electrolytics, but almost certainly the main culprit was just an oxidized spring. And that's kind of interesting to me because you don't really think a lot of times about this connection right here. You know, this interface between the spring itself and the back plate. You kind of just always assume them as one thing normally, and I'll tell you what, that's actually the first time that particular thing has ever happened, where the connection between the spring and the plate was what the issue was. So, you know, hey, I learned something today. And you know, I hope you did too. Hope this was as much of a help for you as it was for me. I look forward to working on the next video, and hope I see you all there as well. Yep, thank you all so much, and can't wait to see you next time. Bye-bye. Not me holding my breath. Oh wow, that's really nice. Pull these through.